Today's topic is limiting and excess reagents, or limiting and excess reactants. And some students will struggle with this early on until they get the hang of it and understand how to set up and solve the problem. But once they do that, it is no more challenging than any other stoichiometry problem. And in a chemical reaction, a lot of times there will be an insufficient quantity of one of the reactants. And this will limit the amount of product that forms. All right, so we're going to limit the amount of product that forms. And the reactant that limits the amount of product that forms is called our limiting reagent. And it is the substance that is used up first, right? And anything that any reactant or reagent that remains behind and has excess material is called our excess reagent. All right, and I will show you an example of this, of what I mean by these two definitions on the next page. Okay, here's an example of what I mean by limiting and excess reactants. Right, let's look at making a cheese sandwich. Right, and for our cheese sandwich, here is our equation, or a balanced reaction. We have one piece of cheese plus 2 pieces of bread is going to yield 1 cheese sandwich. That's our reaction, or our chemical reaction for the cheese sandwich. And I tell you that we have 8 slices of cheese in our refrigerator, and in our cupboard we have 24 slices of bread. So the question is, what is the limiting reagent for making the cheese sandwiches? Okay, and based on our definition, we need to understand which one of these is going to be used up first. So based on our balanced chemical equation, I'm telling you we have, for every 1 piece of cheese, we need 2 pieces of bread. So you can look at this and say, we only have 8 slices of cheese, therefore I should be only make 8 slices of 8 cheese sandwiches from 8 slices of cheese, because I need 1 per sandwich. And 24 slices of bread will give me 12 sandwiches, right? 8 cheese sandwiches, and 24 slices make 12 sandwiches. So they need 2 pieces of bread to make 1 sandwich, and I have 24 slices of bread. So 2 into 24, and give me 12 sandwiches. So in this case, the cheese is our limiting reactant, right? We only have enough cheese to make 8 sandwiches. Our second example looks at car frames, right? We have 10 car frames, and we have 16 wheels. Now, assuming that we need 4 wheels to make a car, when most cars have 4 wheels, we can take 16 wheels, and we can use our standard wheels, and we can do. We need 4 wheels per car, right? And then we can say we only can make that gives me 4 cars, right? And we know that we have 10 car frames. You only need 1 frame per car, but I can only make 4 cars because I only have enough wheels to make 4 cars. So those are 2 examples of what I mean by a limiting reagent in the case of a non-chemistry equation. Okay, now based on a chemical reaction, how do we determine the limiting reagent? Well, we are going to use stoichiometry, right? There's our balanced equations in stoichiometry again coming into play, and we're going to predict what the maximum amount of product that we can form is from each reactant amount given. The one reactant that forms the lowest amount of the product is called our limiting reagent. So basically, we're going to say if we have several reactants and we make material from each one of those reactants, make a product from each one of those reactants, what's the maximum amount of material we can make per reactant? All right, and we'll go through that in a little bit more detail on the next slide. Okay, here's an example of how we are going to use this to show you how to do this with chemistry. So here's our equation, our chemical equation, which is balanced, and it tells me we have 4 moles of aluminum plus 3 moles of oxygen gas will give me 2 moles of aluminum oxide. I'm telling you that we are going to react 7 moles of aluminum and 5 moles of oxygen, right? Now, we need to understand which one of these will be used up first, right? So the question is, what is the limiting reagent, right? And we've already seen the answers here, but let me walk you through how this works, right? Okay, the way I set these up is quite simple. I assume that for each one of the reactants that I'm given and the amounts, that when I do a reaction, I have an excess amount of the other reactant to fully react with all of the material that I'm looking to determine how much I can make from it. So for example, I'm telling you for the first one that we're going to make 7 moles. We have 7 moles of aluminum. And based on my chemical equation here, I know that I have to react it with some number of grams or moles of oxygen. And I assume that I have enough oxygen to fully react with all the moles of aluminum, right? Then I use my balanced equation to determine what is the ratio of the starting material to the product that I need, right? So I start out with 7 moles of aluminum, right? And I know from my balanced equation, that I have, for every 4 moles of aluminum, I make 2 moles of aluminum oxide. So that's where my ratio comes in here. There's my ratio, right? From 4 moles of aluminum gives me 2 moles of aluminum oxide. I have 7 moles of aluminum. So in the end, I'm making 3.5 moles of Al2O3. Okay. Now, the other flip side is that when I look at this from the oxygen standpoint, because I was given 5 moles of that too, right? So I know how much I'm going to make now if I had all 7 moles of aluminum and an excess amount of oxygen. Now I have 5 moles of oxygen and an excess amount of aluminum, right? I know I start out with 5 moles. My molar ratio, here's my molar ratio. I got it from here, where there's 3 moles of oxygen for every 2 moles of aluminum oxide that I can make. All right, so there's my ratio here, 3 moles and 2 moles. And I determined that I can only make 3.3 moles of aluminum oxide. So in this case, my limiting reagent is oxygen because I make the least amount here, right? 3.3 moles is less than 3.5 moles. And then my second question I need to answer is, what's the maximum amount of aluminum oxide can be formed? And it's the limiting amount that I can make, and it's 3.3 moles, right? That's the most I can make from 5 moles of oxygen, assuming that I have enough aluminum, which I do, to fully react with all the oxygen. Okay, you should start and stop the video here, and you should look at this part of the thing here and copy all this down and stop the video and try to do it with according to the technique I just showed you. And you want to find out what is the limiting reagent and what is the amount of water that can be formed. Now I've already given you the answers here, so don't look at the answers first until you react this much oxygen and this many moles of hydrogen, and so you can do that. So copy that information down, stop the video, work it out, and then come back and see how it works, how I set it up on the bottom, and compare your answer. Okay, you're back, and you should try to have done this already. And if you see the way I set it up down here, I'm going to walk through this in a second. Your final answer is that you'll see that hydrogen is our limiting reagent, and we can only make the maximum amount of 3.2 moles of water. All right. So let me walk through how we did that, right? For those of you that struggled a little bit with it. My first equation is I have 1.75 moles of oxygen. Again, I assume I have enough hydrogen to react with all of the oxygen that I'm given, right? So I set up my equation. Here's just the equation here. I'm given 1.75 moles of oxygen. I know from my balanced equation, this ratio, there are 2 moles of water, right from here, for every 1 mole of oxygen, and that's 1 from here. When I do this out and I cancel everything, I get my maximum I can make with 1.75 moles of oxygen is 3.5 moles of water. Okay, so there's so far so good. Now let's look at the next one, and now I'm giving you 3.2 moles of hydrogen, right? And again, the assumption is that you have enough oxygen to react with all the moles of hydrogen, right? And so we set up this equation down here, right? I'm given 3.2 moles of hydrogen. I know from my balanced equation that every 2 moles of hydrogen will give me 2 moles of water. So here's my 2 from here, and here's my 2 up here, and here's my 2 moles of water, and here's my 2 moles of water, right? And in this case, I can only make 3.2 moles of H2O. So since this number is less than this number here, this is less, this is more, this number is less than this number, this is my limiting reagent. And my oxygen is my excessive reagent. Okay, let's try this problem by ourselves first, and then I'll walk you through how it's set up on the next slide. So I want you to copy all this information down on a piece of paper, stop the video, work it out, and then come back and I will walk you through how the solution is made. Okay, I've worked it all out here in nice neat form, and you can see that the limiting reagent in this case, if you've done the math correctly, since this is the smaller amount compared to this, that our limiting reagent is fluorine gas, our excessive reagent is calcium, and based on the limiting reagent yield, our theoretical yield, in other words, the most we can make, is going to be 4.11 grams. And these values will always match, right? The theoretical yield is the maximum amount I can make, and it's dictated by the limiting reagent. Okay, now that you've mastered how to determine the limiting reagent and what the excess reagents are, and how much you can make from the limiting reagent of your product, you should be now able to determine how much excess reagent remains after you do the reaction. So let's go back to our simple problem here of how many cheese sandwiches we can make given the amounts of ingredients that we have. So we know that 2 pieces of bread and 1 piece of cheese gives me 1 sandwich, right? I told you we have 8 slices of cheese and 24 slices of bread. And then I'm asking you now is how much excess reagent remains, or how much excess reactant remains. So we know we can make only 8 cheese sandwiches, right? Because that is our limiting reagent. Here's our smaller amount of these 2, right? 24 pieces of bread gives me 12. 8 cheese gives me only 8 sandwiches, right? I know for 8 sandwiches, based on my balanced equation up here, I need 16 pieces of bread. I have 24 pieces of bread. I only need 16 pieces of bread, so my excess amount of bread is 8 pieces. So how this works is, again, this is what I'm given. This is what I only need based on my limiting reagent. And then this is my excess material remaining. We can use the same thing with a stoichiometry equation from a chemical equation and do the same thing. Okay, so here's an example. I'm going to walk you through this. Obviously, it's already typed out, so you can either fast forward or stop and read it on your own if you want. But here's my chemical equation. I'm telling you that we have, for every 2 moles of sulfur dioxide plus 1 mole of oxygen gas gives me 2 moles of sulfur trioxide. And the question is, what mass of excess reagent remains at the end of the reaction in which 90 grams of sulfur dioxide are mixed with 100 grams of oxygen? So my first step is to determine which one of these is the limiting reagent, right? So these two steps here are the limiting reagent steps. Reagent steps, right? And I determined that my limiting reagent in this case is the lesser of the two materials, and it's going to be the 90 grams of sulfur dioxide. Right? The 90 grams of sulfur dioxide yields 313 grams of SO3. 100 grams of oxygen yields 500 grams of SO3, right? So now I know which is the limiting reagent. My next step is to determine how much of the excess reactant I need to fully react with all of the limiting reagent, right? So in other words, I know I'm going to have excessive oxygen. I need to understand how much of that oxygen I'm given is going to react with all of the SO2 gas in this case. So how do I do that? So the easiest way to do that is I know how much SO3 gas I can make from my limiting reagent of SO2. I'm going to plug that value back into here. That's going to be my starting material. I'm going to work backwards and determine how much oxygen gas I need to make 113 grams of SO3 based on my balanced equation, right? So the first thing I do is I go from grams, I convert to moles of SO3. I use my balanced equation to get my molar ratio of O2 to SO3. And in this case, I need 1 mole of O2 gas will yield 2 moles of SO3. So that's what I have here, 1 mole and then 2 moles. And then I need to convert back to grams of oxygen because I was given grams of oxygen here. If I was just given moles of oxygen, I could leave it here, but I'm given grams, so I need to go back into grams. And I've done that by the molar mass, and it's determined that I need 22.6 grams of oxygen gas to fully react with 90 grams of SO2, right? 90 grams of SO2. Because based on this equation, it tells me I need 90 grams of SO2 and 22.6 grams of oxygen gas to give me 113 grams of SO3 gas. So if this is how much I need, here's how much I was given. I only need this much, and therefore my excess is this much here, right? Here's how much I had, here's how much I really need, so this is my excess amount. It's really that quite simple, all right? So you just have to work it through. It's a multi-step process, but once you get the hang of it, it should be smooth. Okay, what I'd like you to do here is to copy this information down, and don't look at the rest of the slide yet, and work through the problem yourself to see if you can come up with an answer. It's asking for you what is the mass of excess reagent remains at the end of the reaction in which 40 grams of nitrogen are mixed with 58 liters of hydrogen, and you're going to use this balanced equation here. So copy all this down, or stop the video, copy all this down. Don't look ahead on the video, look ahead on the bottom of the slide. Work it out, and then come back and I'll walk you through how it's done. Okay, now that you're back, let's see if this matches how you set it up. So, first thing we want to do is determine our limiting reagent. So step 1 is, what is limiting reagent? What is limiting reagent? And to do that, we set these both up here. We're going to solve first for how much can we make with nitrogen, 40 grams of nitrogen, and then how much ammonia can we make with 58 liters of hydrogen. So here's our ammonia. We want to find out how much of this we can make from this and this. All right. So I start out with 40 grams. Again, remember, we always go back into moles, so here's my convert to moles. I use my balanced equation to get my molar ratio of product to reactant, in this case is my reactant, here's my product, and it tells me I need 1 mole of N2 gas will give me 2 moles of NH3, and then I go back into grams once I get the molar ratio, and I determine that I'm going to make 48.6 grams of NH3 gas. I do the exact same process for the next one. In this case, I'm getting 58 liters of hydrogen. Right, so here's my 58 liters. Now, we're not finding the grams of hydrogen because we're given liters, so we have to use the other part of the mole triangle. And we know that 1 mole of hydrogen gas is 22.4 liters of hydrogen gas at STP. Everything else is the same process, right? Now we go back to our balanced equation and we look at our molar ratio of reactant to product. In this case, it's 3 moles of hydrogen gas. Gives me 2 moles of NH3, and there's my ratio here. And then I go back and do this calculation to calculate the number of grams of ammonia gas that I make per mole, and it determines that I'm only going to be able to make 29.3 grams of ammonia gas. So in this case, our limiting reagent is the smaller of the two again, and that's our limiting reagent. So hydrogen is our limiting reagent. Now, it's asking me what excess reagent remains, and we know that we're going to have no hydrogen gas, and we're going to use this number here to solve for the rest of this, right? And so this is our start point to determine how much of nitrogen we need to make to fully get all of this material back, because we're going to react all of the hydrogen, right? So we know that this is how much I can make. This is the theoretical yield. I go back into moles again. There's the mole ratio, right? Convert to moles. There's my grams are canceling. I get moles of this. I go back to my balanced equation, and I know that for every 2 moles of ammonia that I make, I need 1 mole of nitrogen gas. And then I go back to convert back out into grams again. And I know that I only need 24.1 grams of N2 gas to fully react with all 58 liters of hydrogen to give me 29.3 grams of ammonia. And when I do that, I go to my final equation. This is how much nitrogen I was given. This is how much nitrogen I actually need, and therefore my excessive amount, this is my excess nitrogen, is almost 16 grams of material. So if you work it out that way, you should be able to solve any one of these problems. It's just a step-by-step process, and don't lose track of where you are. Okay, here's our last slide in this tutorial, and it's going to be a do-it-yourself one. So I'm giving you the information you have here. Here's our balanced equation, right? We're going to make calcium oxide plus water. Gives me calcium hydroxide. These are the molar masses for each one of these materials, so you have something to work with. You don't have to go look on your periodic table. And I'm asking you to look at this set of conditions and solve the answer the questions there. And so this is the answer here. So you should stop the video now, copy this information down that I've given you up here, all this material here, and work through the problem, and then self-check at the end of the thing when you're done. If you have any questions, you can come find me.